Today we are talking about charts and graphs, and particularly the different types of charts and graphs that you can use and how to best interpret them and when to use which type of chart or graph. So to start off with, you want to choose the design on the basis of a couple of things. First of all, you want to think about the level of measurement. Are you looking at primarily nominal level data or numeric level data? The level of measurement is going to change the type of graph or table that best illustrates the data. You also want to think about the study objectives. Why are you using a chart or graph? What's the purpose of the chart or graph? And then lastly, think about the targeted audience. Is this an audience that is not familiar with statistics and so you want to make things simpler, or it's an audience that likes to see things visually? Then a chart or graph would be appropriate. Now, second, you want to make sure that you're simplifying the data, not complicating the data. A chart or graph should help you to see trends or patterns and not confuse the viewer. And then third, your chart or graph should be self-explanatory. In other words, you shouldn't have to stand there and explain to those around you or to your audience what is in the graph. Should they just grab a handout, they should be able to understand exactly what's going on in the graph or chart without you having to stand and explain. And then lastly, you need to make sure that you cite your sources. So indicate where the data come from. Basically, the chart or graph should be able to stand alone. If it were to fall out of the paper and not have your written work with it, it should have all of the information necessary in order for people to know where it comes from and what it's saying. So let's start with a very basic form of chart. Let's start with a pie chart. You've all seen a pie chart, I'm sure. Pie charts are best for nominal or ordinal level data, and basically it's a circle that's dissected or sliced from its center point, and each piece or each slice represents some sort of proportional frequency of a category. So here's an example. This is a good example of a pie chart. We have a nominal level data. We're asking what browser did people use, and this is a survey from April 2012. And you can see that we're looking at Internet Explorer, Firefox, Chrome, Safari, and a browser called Opera. And so because there are just a few categories, it's very easy to see the data. And it's easy to see which browsers make up the biggest segment of the browser population. And then you can also see that the creator of this pie chart, is wanting to illustrate something about Internet Explorer, and so they've kind of separated that piece of pie out. So this is a good example of a pie chart. This is a bad example of a pie chart. This is basically population by state, and so it's showing the most populous states get bigger pie chunks. The problem with this is that there are so many pieces of pie that it's overwhelming to your eyes. It's also difficult for the labels to make any sense because there are so many labels. This would be better represented in a different type of chart. So this is a bad example of a pie chart. When you are looking at a pie chart, if we go back to, say, the good example, when you're looking at a pie chart, you are wanting to interpret it and by basically describing what you see in words. So kind of identifying maybe the largest and smallest pieces of the pie or comparing pieces together. So for example here, it looks like Firefox and Chrome have a very similar number of users. So they each make up slightly more than a third of the browser usage in April 2012. So you could say something like that. And so your interpretations of a pie chart are basically putting this chart into words. So should your paper get separated from the chart, it would be there in writing in the paper. So a second type of chart is a bar chart, and bar charts are also good for nominal and ordinal level data. And it's basically a series of vertical or horizontal bars with the length of bar representing the percentage frequency of a category. So here we have an example of a very simple bar chart where a frequency of visit, and then you can see that we have the percentage for each of those categories represented by the bar. So daily you can see it's just below 20%, twice a week is about 35%, weekly is looking at about 65%, and then monthly at almost 90%. And so this is a very simple bar chart. And for a bar chart, when you are analyzing it or when you are interpreting a bar chart, you're going to want to point out again the highs and the lows and kind of compare the different categories to one another in your interpretations. In addition to a regular bar chart, you can also make what are called clustered bar charts. And a clustered bar chart allows you to look at more than one variable at a time. So it allows you to compare two groups by splitting the data into groups and then analyzing the frequencies for each group. So in this example, we have number of visitors, and we can see that it's divided into adult visitors in red and child visitors in blue. And we can see April, May, June. So we're looking at three things: the number of visitors, when they visited, so April, May, or June, and then also whether those visitors were adults or children. And so we have a comparison here. So in April, you can see that there were more adult visitors than there were child visitors. But in May, we have a flip where there are now more child visitors than adult visitors. So clustered bar charts really help you to analyze or view more than one variable at a time. So if you're trying to divide things maybe along lines of race or sex or social class, a clustered bar chart will allow you to make those comparisons. And so they are very helpful for that. Now, similar to a bar chart is something called a histogram. And a histogram is best for interval or ratio level variables, so our numeric variables. And this is one that is showing you, if you look at the bottom here, what is the highest grade in elementary school or high school that you finished and got credit for. And so it's showing you the frequency or how many people selected that answer. And so you can see that there are very few people down here at the bottom who had 0 years of education, and then it starts to build until you get to 12 years, which would be kind of high school graduation. Goes down again, you go up, and this is an associate's degree, go back down, a bachelor's degree, a master's degree, doctoral degree. And so this allows you to kind of look at those trends, kind of look at how the peaks and valleys form. And so when you're interpreting a histogram, that's what you're looking at. You're looking at that flow, those peaks and those valleys. And so a histogram really is a bar chart. We're pushing the bars together because they're not discrete categories. Another chart that you can use with interval and ratio level variables is what's called a polygon or a line graph. And it just shows frequencies that are represented by dots along the XY axis, and then they're connected by straight lines. So this one shows the number of hours worked last week, and you can see at 20 hours a week, and then you have a spike at 40 hours a week, which is what we would expect in talking about hours worked per week. So again, in a polygon and line graph, you're going to interpret this much the same as you would a histogram, where you're going to be looking at those peaks and valleys. So those are your different types of charts and graphs, and all of these can be done in Microsoft Word or Excel or even sketched out by hand. I'm going to show you in our next video how to do these in SPSS.